Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The heat of hydrogenation, ΔH_HYD, is the enthalpy released when 1 mole of an alkene is hydrogenated to the corresponding alkane. A more negative heat of hydrogenation means more energy is released, which corresponds to a less stable, higher energy alkene. Conversely, more substituted, more stable alkenes have less negative heats of hydrogenation. Step 1. Identify the degree of substitution of each alkene's double bond. A. Vinyl cyclohexane, the double bond is CH2 is equal to CH, terminal, monosubstituted vinyl group attached to cyclohexane. The double bond carbons bear one alkyl substituent, total monosubstituted alkene. B. Methylene cyclohexane, exocyclic is equal to CH2 on cyclohexane. The sp2 carbon of the ring bears two ring carbons, but the exocyclic is equal to CH2 carbon bears none. Overall, this is a 1,1 disubstituted geminal alkene. C. The structure shown is an exocyclic double bond from cyclohexane to C. CH3 is equal to with an additional methyl, making it a trisubstituted alkene. The exocyclic carbon bears one methyl, and the ring carbon bears two ring carbons. This is more substituted, and therefore more stable, less negative heat of hydrogenation. D. 1-methylcyclohex, 2Na, endocyclic trisubstituted double bond. The two ring carbons of the double bond each bear one additional carbon substituent, and one also bears the methyl group, trisubstituted, relatively stable. Step 2. Rank stability. More stable is equal to less negative ΔH_HYD. Most stable, least negative ΔH_HYD, C. Trisubstituted exocyclic, and D. Trisubstituted endocyclic are most stable. Moderately stable, B. Disubstituted exocyclic, methylene cyclohexane. Least stable, most negative ΔH_HYD, A. Monosubstituted terminal alkene, vinyl cyclohexane. Step 3. Key reasoning for a vinyl cyclohexane has a monosubstituted terminal vinyl double bond, CH2 is equal to CH, which is the least substituted among the four options. Less substitution is equal to less hyperconjugative inductive stabilization is equal to higher energy alkene is equal to most energy released upon hydrogenation is equal to most negative heat of hydrogenation. Step 4. Why other options fail? B. Methylene cyclohexane is disubstituted, more stable than A, so less negative ΔH_HYD than A. C. The trisubstituted exocyclic alkene is even more stable, so even less negative ΔH_HYD. D. The trisubstituted endocyclic alkene is similarly or more stable than B, so less negative than A. Therefore, the correct answer is A. Therefore, the correct answer is option A.